So this video is on the different types of solids that we're going to encounter in our everyday lives and sort of an overview of those different types of solids. So the first one that I have for us is just a little example of magnesium turnings. So this is a metal. So this is a metal solid. I've got little chunks of magnesium. Another example would be this wire. So this wire is made of nickel. So this is a nickel wire. And these are examples of metals, right? If we saw these out in our everyday lives, we might say, yeah, those are metals. I can recognize those as metals. So that's our first type of solid, metals. Metals are really sort of unique and special in that they can conduct electricity. So this wire here, right, we can conduct electricity through that wire. And the reason that they are able to conduct electricity is because if I think about the structure of a metal, so what I'm drawing here would just be sort of my different nuclei. So each of those magnesium nuclei, right, it's going to have a positive charge. So that's where all the protons are, protons and neutrons. And then the electrons are going to be sort of delocalized and able to flow between the different nuclei, right? So the electrons are able to move through this entire metal solid. That's how this wire is able to conduct electricity. So very special property of metals. The next solid that I have, for you is an ionic solid. So here I've got sodium sulfate, and we can sort of see, what these crystals look like. So the next one is ionic compounds. And ionic compounds are as you might expect, ions, right? That's the key. So we've got ions, and these are going to be held together by charges, positive and negative, attracted to one another. So here I've got sodium sulfate, right? So Na2SO4, sodium Na2, that's going to be my positive charged ion, and then SO4, that's going to be my negative charged ion. I've got another example here of calcium chloride, so Ca2+ and Cl-, and we can see these, solids, they're a little bit different looking, right? So we're going to have different ionic solids, and again, they're just going to be held together by positive and negative charges that are attracted to one another. So if I wanted to think about, this calcium chloride, for instance, I'm going to have a Ca2+ ion, right? That's going to be an ion, and that's going to be attracted to individually two separate Cl- ions, and there's going to be an electrostatic attraction holding those, that solid together. That's what's going on in this calcium chloride situation. So this lattice, right, this is going to be a big lattice, and they're all going to be held together. And in the solid form, they're not going to conduct electricity very well. There's no good way for electrons to sort of move through these systems. But if we dissolve these, then in water, then we will be able to conduct electricity. So that's a special property of ionic solids. When dissolved, will conduct electricity. The last one that I've got some examples for and we're going to talk about is what we call molecular. And this is really the main one and most important one that we really need to talk about. And this is basically everything else. So that's a really big category, basically everything else. The first example I have for you here is iodine. So these are iodine crystals. We can see them in here, and you can see almost a little purple color. So that's iodine. So this is just I2, and this is a solid. So at room temperature, iodine is a solid. It sublimes very easily, but here's my first example of a molecular solid. I've got another example here of triphenylphosphine. So here we've got triphenylphosphine, again, this sort of white crystally stuff. The structure of this one is shown here. Let's put it down here. So triphenylphosphine has this structure here. It's got a it's got a phosphorus in the middle, and then I've got phenyl rings. These are just C6H5 rings. So each one of these points, again, is going to be a carbon. So C6H5 rings bonded to that central phosphorus, and I've got a lone pair of electrons here. So again, at room temperature, I've got a solid here. And another example would be mineral oil. So the last example I have here. So this is mineral oil, and we can see that it's pretty viscous. Almost spilled it. but it's sort of just this liquidy structure. And this is what mineral oil is. So mineral oil is basically a long chain alkane. So again, all carbons and hydrogens. And this could be 9 carbons or more. And we're going to have this sort of liquidy substance. So like I said, basically everything else. And what's special about molecular compounds, and really why we're getting into this, is that these are held together by intermolecular forces. So that's the key. So that's why we're seeing all these different properties from our solids, right? Iodine, triphenylphosphine, and mineral oil. We've got all these sort of different properties, and all of that is based off of the different intermolecular forces at play holding these molecular solids together. So the next thing we need to really talk about is what are all these intermolecular forces and how can we understand the different properties that we're observing.